Let's understand basics of blockchain technology and how it applies to industrial IoT. What is blockchain? Blockchain is a decentralized digital ledger that records transactions across multiple computers in a secure and tamper-proof way. Instead of relying on a central authority, blockchain uses distributed consensus to validate and store data. Each block contains a set of transactions, and once added, it cannot be altered without changing all subsequent blocks. This makes blockchain highly secure, transparent, and trustworthy. Main components of blockchain are decentralization. Data is distributed across multiple nodes, increasing transparency and fault tolerance. Cryptography ensures security using hashing and encryption. It protects data integrity and enables secure transactions. A hash function is a mathematical algorithm that takes input data and converts it into a fixed length, unique, and irreversible output, used to ensure data integrity and security in blockchain. Common hash functions are SHA-256, SHA-3, a lightweight hashing method designed for low power and resource constrained devices, can be used in industrial IoT. It provides data integrity and security with minimal processing, memory, and energy consumption. Consensus mechanism, a method that all nodes use to agree on the validity of transactions. Proof of work is one of the methods where nodes solve complex mathematical puzzles to validate transactions. In proof of stake, validators are chosen based on the amount of stake. Smart contracts, self-executing programs stored on the blockchain that automatically enforce rules and agreements. Distributed ledger, a shared database where all transactions are recorded across multiple nodes, making it tamper-resistant. Last is mining, the process of validating transactions and adding new blocks to the blockchain, often involving computational effort. Another important concept within blockchain is digital signatures. Digital signatures use cryptographic techniques to verify the identity of sender and ensure data has not been altered. In blockchain systems, every transaction is signed using a private key and verified with a public key. This ensures authenticity, integrity, and non-repudiation. The sender cannot deny their involvement in the transaction. Now, why is blockchain required in industrial IoT? Industrial IoT involves a large network of connected devices such as sensors, machines, and control systems exchanging data. One of the biggest challenges in IIoT is ensuring data security, integrity, and trust across multiple devices and stakeholders. Blockchain addresses these challenges by providing a secure and decentralized framework. It eliminates single points of failure, reduces the risk of cyber attacks, and ensures shared data cannot be tampered with. Combined with digital signatures, blockchain ensures only authenticated devices can send valid data into the system. Additionally, blockchain enables transparent tracking of machine data and operations in industries like manufacturing, energy, and supply chain. Next, let's look at some key applications of blockchain in IIoT. One major application is supply chain management with real-time tracking and traceability from production to delivery. Another application is predictive maintenance by securely storing machine data to analyze performance and predict failures. Blockchain is also used in energy management to enable secure peer-to-peer energy trading between devices and grids. In industrial automation, blockchain can enhance device authentication and secure machine-to-machine communication. Now, what tools are required to create and implement blockchain solutions for IIoT? Blockchain works by storing transactions in blocks, securing them using hash functions, and validating them through consensus algorithms. Smart contracts then automate execution, ensuring secure, trustworthy, and decentralized operations. First, you need a blockchain platform such as Ethereum, Hyperledger Fabric, or Corda. Second, smart contract development tools like Solidity are essential for writing contracts on platforms like Ethereum. Third, IoT platforms such as AWS IoT, Azure IoT Hub, or Google Cloud IoT managed device connectivity and data flow. Fourth, development frameworks like Truffle Ganache and Hardhat help test and deploy blockchain applications. Finally, integration tools and APIs connect IoT devices with blockchain networks, enabling automation and seamless communication. To summarize, blockchain provides a secure, decentralized solution for managing data in industrial IoT systems. It enhances trust, improves security, and enables new applications across industries.